So this is the question paper. Uh, let's go through it and try to come up with different solutions. So let me open the question paper. Question 6.1. The empirical formula for a certain compound is to be determined. On analysis, a sample of the compound was found to contain 48.7% carbon, 8.1% hydrogen, and 43.2% oxygen. Then the first question is define empirical formula, which is 2 marks. So if you can check, if you add 48.7% plus 8.1% plus 43.2%, you're gonna get 100 gram of a sample, which is a total 100% of the carbon, hydrogen, and oxygen. Or if you go to your periodic table, you can go and check carbon has a mass of 12 and hydrogen has a mass of 1. That's why carbon percent in terms of percentage is 48.7% compared to hydrogen with the lower mass compared to carbon, and also oxygen is 43.2, which is of it has a mass of 16 gram. I'm surprised because the percentage of hydrogen was supposed to be more than the carbon. But anyways, as long as it adds up to 100%, it makes sense. How do we define empirical formula? 6.1.1. Let's try to define empirical formula. Empirical formula. Okay, this is how you define empirical formula. Empirical formula. Okay, it is the simplest whole number ratio of atoms in a compound. You see, the simplest whole number ratio of atoms or elements or molecules in a compound. Simplest, let me try to decrease the size. You can see empirical formula is the simplest whole number ratio. The simplest whole number ratio of atoms in a compound. Okay, I hope you can see the let me write simplest whole number ratio of atoms or element. Yeah, atoms or element. Simplest whole number ratio A of atoms or element in a compound. That is empirical formula. So let me decrease this. So this is the definition. Okay, now let's go to the next question. Determine the empirical formula of the compound. You see, show all calculations, 4 marks. It's simple. The only way you need to do is to formulate your own table. Like you will have a table. Let me decrease this again. Put it here. 6.1.1, 6.1, 6.1.2. Let's formulate a table. You're gonna have something like this. You see, so we're gonna have element inside here. Element. We're gonna have. Let me write it in a simple, visible way. Element, element, and we're gonna have mass in grams, mass per grams, mass per grams. We're gonna use the formula number of moles divided by molar mass, mass divided by molar mass, and we're gonna have the simplest whole number ratio. Let's try to formulate a table like this one. Simplest whole number ratio. Well, I don't think it's visible. Let me delete everything. I don't like to write things that are not visible, that myself I can't even see. Let's try to make that table again. Let's try and make that table again. So we're gonna have element, and we're gonna have mass per grams, and we're gonna have the formula number of moles equals to m divided by molar mass, and we're gonna write this in simplest ratio. So on this empirical formula we got carbon, hydrogen, oxygen. So we know that let's go back. We know that for carbon they gave us 48.7%, which is the percentage must become a mass. You see, 48.7% should become our mass, which is 48.7 grams. 8.1% is the mass, is 8.1 grams of hydrogen, and 43.2% of oxygen is the mass. So we just have to fill up this table. Let's try to fill up this table. So yeah. So let's see. Let's try to minimize this table anyway. Try to write it here. So we're gonna have carbon. We have 48%, which will become a mass, 48.7 gram. Hydrogen we have 8.1 gram. Oxygen we have 43.2 gram. And then let's go to the formula. You know this formula: number of moles divided by mass divided by molar mass. Number of moles equals to mass divided by molar mass, which is b small m divided by b capital letter M. So mass is 48.7 divided by 12, 8.1 divided by 1, and 43.2 divided by 16. I'm dividing with the mass. When you check your periodic table, the mass of carbon on your periodic table is 12 grams. Mass of hydrogen is 1 gram. Mass of oxygen is 16 gram. So simplest whole number ratio. This is how you write your simplest whole number ratio. If you divide 48.9 by 12, 48.7. I made a mistake here. 48.7 by 12, you're gonna get 4,053 moles. And then no, actually I don't have to write this here. I need to calculate number of moles and fill up them here equals to the answers, So after that, I'm gonna have 4,0583 moles, and for hydrogen I'm going to have 8.1. For oxygen I'm going to have 2.7. So when you check these numbers, you see the lowest number, we divide everything by the lowest number. 4,05 is not the lowest number, 8 is not the lowest number, 2.7 is the lowest number. So I have to divide 4,058 by 2.7, and which is going to give me what? Carbon, it will give me 4,08 divided by 2.7, you're gonna get 1.5. And hydrogen, is 8,1 divided by 2,7. We're gonna get 3 is 3, right? 3. And oxygen is 2,7 divided by 2,7, which is 1. So if you check, I have to write my empirical formula in terms of CHO. So here you can see we got 1,5 for carbon. So to make it a simplest whole number ratio, I have to multiply by 2 for everything. Multiply by 2 everything. So I'm going to get my empirical formula after that. Let me show you. uh, I'm going to get my empirical formula. um, so if I say 1,5 times 2 is going to give me 3. 3 times 2 6. 1 times 2 2. Therefore my empirical formula is going to be C3H6O2. See, this is the answer they're looking for. C3H2O6. This is how you determine your empirical formula. It's not that difficult or complex. It just needs you to know the elements. Okay, you have carbon, nitrogen, oxygen. In most questions, they will bring carbon, nitrogen, oxygen. And after that, you need to convert the percentage to mass. You know, the percentage must be mass. And after that, you need to know your formula. N equals to M over M. Number of moles equals to mass divided by molar mass. Small m is mass, bigger m is smaller mass. Smaller mass, just go to your periodic table and study all those elements on your periodic table. Uh, all those elements, they got atomic number, mass number, electronegativity. So we usually use mass number when we're calculating empirical formula on molar mass. Okay, after that you just have to calculate the number of moles, find the simplest whole number ratio, divide that number by the smallest number, divide carbon, hydrogen, nitrogen, and oxygen. And then after that you're gonna get the ratio, and that number, it becomes our empirical formula. And if the number you got commas instead of simplest whole number ratio, then you need to multiply by 2 so that you make it simple. Then 1,5 times 2, 3 times 2, and 1 times 2, then you will get your empirical formula. Simple as that. And then let's go to the next question. The molar mass of hydrated copper sulfate is found to be 249,5 gram mole per mole. Um, the formula of the hydrated copper sulfate is CuSO4xH2O. Calculate the number of moles of water of crystallization X in the compound format. This is not really complicated, honestly. Let me wipe out everything. And we do this question 6.2, right? We do this question. Water of crystallization is so simple and 3 marks. You see, you need to make sure you get these marks. The first thing you gotta do, okay, 6.2. We know that we have this salt, copper sulfate dot XH2O. We got this salt. We are we have to determine X in this compound, you know. So how do we determine X? So we got a molar mass of copper sulfate. We got, let me go back. We got the molar mass of hydrated copper sulfate is found to be a 249,5 grams. Okay, hydrated copper sulfate. So in this question, you need to always remember that We have hydrated copper sulfate and unhydrated copper sulfate. Let me show you. The molar mass of hydrated copper sulfate equals to 249,5 gram per mole, and the molar mass of unhydrated, let's try to calculate molar mass of unhydrated copper sulfate. So if you go to your periodic table, you just check copper, how much copper do you have, and sulfur and oxygen, then the total will give you 159,5 grams per mole. So once you have something like this, we know that you have copper sulfate molar mass and of hydrated and molar mass of unhydrated copper sulfate, and then therefore you need to find the mass of water. Mass of water, how do you determine mass of water? You just say 249,5 minus 159,5, and then it will give you 90 grams. We're gonna use this 90 gram when calculating the number of moles of water, which will end up giving us the x in that situation. So we're gonna use n equals to m divided by molar mass. We know that we found the mass of water. So the molar mass of H2O is like 18. Of course, go to your predictable, calculate the molar mass. I will teach you how to calculate the molar mass on the next video. So just go to the predictable. We have mass of hydrogen, which is 1 times 2 plus 16 of mass of oxygen, and then 90 divided by 18. You're gonna get 5 moles, and this 5 is the x that we were looking for. 5 moles. So therefore, you have CuSO4x XH2O, which becomes what? Therefore, CuSO4 dot 5H2O. This is what they are looking for. This is what they are looking for. Okay. This is how you calculate this water of crystallization questions. This is how you do it. Okay. This is how you do it. It's very important that you learn how to determine this X in the compound. You see the X in the compound, CuSO4XH2O. And let's go back. I only had these 10 marks to teach you, to show you how you can do it. You can see, so we have the molar mass of copper sulfate, and we also need to determine the molar mass, the hydrated copper sulfate and the unhydrated molar mass of copper sulfate, and then we need to subtract those two masses, which will give us the mass of water, which is 90 grams. And after that, we're gonna use that n equals to m over m formula, which is at the back of your question paper, and then you sorry, you get that 5, you use it on your equation, and then you're done just like that. This is photo of crystallization. So anyways, thank you for watching the video. I'll see you in the next video.